Hey everyone, it's Traxler. Sorry I'm not there. I'm out of town with my daughter. Doing what I can. As Tom told you, since I'm out of town, I'm going to make everything due later next week. So you'll have plenty of time to do it and plenty of time to get help if you need to. But I thought we'd go over some of the oxidation number stuff, and hopefully you can get that done on your own either today or tomorrow. But again, it won't be due until next week. So the idea is, if we understand what's going on with the electrons in a reaction, we can balance the reaction and we can understand the reaction. So to do that, we can follow a few simple rules. So the rules are up here. We started it on Tuesday or on Monday, looking at the rules. So let's just keep going with the rules. So rule number one was a monoatomic ion is equal to its charge. So we said chlorine's -1 because it's a single atom and its charge is -1. Okay. The oxidation number of an elementary substance is 0. So the idea is an element can't take electrons from itself. So even though there's two bromine atoms here, each bromine atom has gained and lost 0 electrons. So its oxidation number or its oxidation state is 0. You could apply that to copper. So notice copper, either the first rule or the second rule, you could think of it's a single atom, so it has no charge, so it's 0, but it's also a single element, so it's 0. Cool? Fluorine is the most reactive of all chemicals, and it reacts in one way. It takes 1 electron. So fluorine always takes 1 electron. So if I have 2 fluorines, then I have taken 2 electrons. The 2 fluorines combined have a -2 oxidation state. SF6 would be -6 from the fluorines. Cool? The oxidation number of hydrogen is always +1 wherever it is when it's hooked up with something. When hydrogen is alone, it's 0. Hydrogen, basically the idea is hydrogen reacts only to form compounds where hydrogen is +1. Oxygen is always -2, except in these crazy peroxides. A peroxide would be something like Na2O, and we'll talk about that one later. Okay, so basically, if we know those few things, then we should know whatever is hooked up to those few things. So if fluorine is always -1, then these 2 fluorines are -2, and therefore chlorine in this situation would have to be +2, because the oxidation numbers always add up to whatever the overall charge is on the molecule. So since ClF2 has no charge and fluorine has to be -2, chlorine has to be +2. So in CH2O, oxygen has to be -2, hydrogen has to be +1, and there's 2 of them. So therefore the carbon has to be 0. Cool. Okay. So let's try one of these uglier ones, like say chromate ion. The oxygen in the chromate ion has to be -2, and there are 7 of them, so that's -14. Cool. The overall charge on the molecule is -2. Therefore, the 2 chromiums combined have to be +12. Therefore, each chromium has to be +6. I know this sounds pretty complicated, but if you read about it in the book and you try some of these problems, it'll work. And that's a very typical AP test question, where they'll give you one of these chemicals and just ask you, what are the oxidation numbers? The real difficulty comes when you try to apply it to an equation. So look within an equation, and then it can tell you what's going on in the equation. So here's copper. According to rule number 1 or 2, it's got an oxidation number of 0. Silver has an oxidation number of +1. Over here, copper has an oxidation number of +1. and silver is 0. So therefore, copper has gone from 0 to +1, so it has lost 1 electron. It has been oxidized, and silver has gone from 1 to 0, so therefore it must have gained an electron. It must have been reduced. Cool? And then we can see, and then the overarching law becomes, within a chemical reaction, oxidation and reduction are always balanced. So here, iron is 0 and oxygen is 0. Remember, oxygen is -2 when it's hooked up with something. It's not hooked up with something, so therefore it's 0. Here, the oxygen is -2 because it always is. There are 3 of them, so it's -6. So therefore the ions have to be +3. Sorry, the ions have to add up to +6, so each iron has to be +3. So iron went from 0 to +3, and oxygen went from 0 to -2, and that's why iron oxide has that formula, so that the electrons balance. Cool? If we understand that within an equation everything has to balance, then we can balance equations like the ones on the back, right? So here, iron is going from 3+ to 0, so iron is gaining 3 electrons. It's being oxidized. Here, zinc is going from 0 to +2, so therefore it's losing 2 electrons. It's being reduced. Well, that therefore tells you that this equation is not balanced. We can't have 2 electrons lost and 3 electrons gained. So the balanced equation for this, you'd ask yourself, if one's gaining 3 and one's losing 2, what's the smallest number that we can use to cancel them? That's 6. So we would need 2 irons and 3 zincs. And now we have the balance reaction. Cool? The rules are up here. Notice how I followed them. I assigned an oxidation state for each atom. I used my tie lines to show oxidation and reduction, and then I changed the coefficients to balance the gain and loss of electrons. Cool? This one's a little more complicated because notice when you look at it originally, on this side of the equation, you've got a lot going on, and you have hydrogen. On the right, you have no hydrogen. So somewhere in there, we're going to have to add hydrogen. Okay? But let's do just the normal. Identify the atoms that are oxidized and reduced and balance it. So here's lead. This lead is 0 because it's all by itself. It has neither gained nor lost electrons. Oxygen is always -2, that's -4. So this lead is +4. Cool. Hydrogen, we don't worry about. Oxygen, we don't worry about. The sulfur, so if you notice, the sulfur here is part of SO4, and it's the same over here. So the sulfur is not changing in any way. If you want, you could figure out that the sulfur in here is +6, and it's going to be +6 over here as well. All right? But the lead over here, so sulfate, the ion is 2-, so this lead has to be +2. So notice, lead here is turning into +2. It is losing 2 electrons. Here, lead is going from +4 to +2, so it's gaining 2 electrons. Cool. We have 1 lead here, 1 lead here. So this equation, as far as the electrons go, is balanced. But we have to fix the rest of it. So notice we have 6 oxygens on this side and 4 on this side. So we need to